This segment is, what is the role of emergent properties in chemistry? How do new elements and molecules emerge and innovate in the inanimate universe? What chemical elements make up a water molecule? We're probably all familiar. H2O, 2 hydrogen atoms, 1 oxygen. These are the building blocks bonded together to form a new structure, a higher form of complexity. What is a basic property of water? Water is, well, wet. But where did this property come from? Take the pieces of the puzzle apart. Is hydrogen wet? Is oxygen wet? No. Can you water a plant by spraying some hydrogen gas followed by some oxygen gas at it? Indeed, not very effectively. In fact, oxygen is the plant's waste product. Why is it the combination of 2 hydrogen atoms and 1 oxygen atom into a single molecular structure seems to unlock new qualities? How about another one? Salt. It is composed of sodium chloride. What does salt taste like? It tastes, well, salty. But does chlorine taste salty? Would you put it on your French fries? No. Would you want to lick pure sodium? Not unless you wanted to burn off your tongue. Yet, when you put sodium and chlorine together, you get salt, a very useful and historically very important resource. These are examples of emergent properties in chemistry. When complex structures form, the combination of their building blocks can exhibit properties that are greater than the sum of their parts. Out of the combination of a collection of ingredients, new things, as they say, emerge. The same goes for the combination of cells that make up your brain and the consciousness that results. Put movable metal type and the mechanics of a wine press together, and you get Gutenberg's revolutionary printing press. From the ability to produce an unheard of amount of literature for society to benefit from, a scientific revolution results. Each emergent property tends to interact still more with other emergent properties in a cascade of change. Put hydrogen and oxygen together, and you get water. Water was a friendly liquid in which the first organic chemicals formed on Earth evolved and produced all life, which is still so dependent on water in various ways. All of these emergent properties are forms of blind innovation in the universe, and they all belong to a continuum. Take again the simplest of all atoms, hydrogen, which is the most abundant kind of atomic matter in the universe. Without the intercession of stars, no higher forms of complexity, like planets, life, or culture, would have arisen. 1 proton paired with 1 electron, forming hydrogen, was all we needed to lay the foundations for a structure that grows higher and higher, with each new level being more intricately built than the one before. It is often said that the recipe for humans is to take some hydrogen and wait a few billion years. Hey presto, you've just cooked up a chartered accountant. From dense collections of hydrogen, you have stars, which forged in their bellies all the elements up to iron. And the largest stars exploded in supernovae, producing still heavier elements, until we arrive at the 92 naturally occurring elements in our universe. These came together further still to produce all sorts of molecular structures. And throughout our history, humans have deliberately manipulated their properties, rather than just leaving it to blind innovation, and have produced amazing effects that are life-enhancing, new chemicals for industry, clothing, agriculture, and medical treatments. Carbon is forged in the belly of a star, by no means a very complex element compared to, say, gold or uranium. It still clocks in with 6 protons, 6 neutrons, and 6 electrons. It forms the basis for life on Earth. It also is one of the most pliable of the elements, forming the basis of 90 million out of the 100 million molecular combinations that we know to exist. A molecule is even more complex, since it is a string of elements together and can exhibit new and astounding properties. It is the next layer of complexity above the atomic bedrock. When we get to structures as intricate as life, one DNA molecule has a couple 100 billion atoms strung together in a highly complex process. The organic structures to which DNA belongs are even more impressively structured, requiring a vast amount of building blocks and connections. The body of an animal is hugely complex in comparison to what existed before stars. A brain has more nodes and connections than anything found in inanimate nature. Consider further the complex human web formed by a tangled network of billions of those brains, with their societies, inventions, and adaptations that can accomplish astounding technological feats. You begin to understand the pattern of rising complexity that unites 13.8 billion years of history and all beds of knowledge. This continuum goes all the way back to the life forms that invent technologies, the organic molecules that make up the life forms, the chemical elements that make up the molecules, and even further, the protons, neutrons, and electrons which come together to form the emergent properties of a simple chemical element itself. Going deeper, we have the emergent properties of quarks when they come together to form a proton. All of these structures breed traits and qualities that are far more than the sum of their parts, and these emergent properties beget more emergent properties. You might well ask, what does all of this inanimate emergence science stuff have to do with innovation in human society and our own lives? Well, unlike the universe, the solar system, and life, which came together by the crashing together of blind ingredients operating under the laws of physics, we humans have the ability to direct innovation, to direct emergence. This is because, thanks to our consciousness and our collective learning, we sit atop one of the most complex systems ever, global society. With the power to direct innovation, to anticipate and design for it, it helps if we understand the fundamentals of innovation. We must seek out different building blocks to combine in order to create outcomes that are greater than the sum of their parts. This will go for any innovation or solution to a complex problem that you can conceive. You must figure out what the component parts to innovation are, anticipate its effects, and figure out how to organize, mobilize, and bring all those variables together to produce the desired results. Whether the process is blind or directed, the fundamentals are the same. Regardless of whether you are seeking to invent a new technology, devise a new policy to a big problem, come up with a business plan that is good for you and the economy, or come up with a form of literature or art that will resonate with your audience, you are always engaging in the same thing, the creation of new emergent properties. You are engaging in a process that is as old as the universe itself, but with a little more gusto and advantage than most emergence, given to you by one very important tool, your mind. So identify those building blocks and see what emerges.